Good evening, everybody. So let us start our class tonight. So we are almost at the end of third quarter of this course. So we have completed almost the foundational, basic, and the top content. So the remaining stuff are very actually will be interesting and not too much hard. So after tonight, so since I think I am a little bit ahead than other section. Okay, another professor. So then I'm thinking that let us make this class something different and collaborative. So your section is section 3, right? You're in section 3, right? Okay, so everybody please start your computer and log in to D2L. And you see that I have submitted a discussion question. So on the discussion, I want to see if everybody can see this. And you see that in the discussion, I post a question similar to your recent test. Okay. So there might be this question may be repeated partially for your final. Okay, but I submitted this in order to ask you to join collaboratively. Okay, so everybody please, okay, try to submit. Do you see any reply button? Anybody see any reply button? You see reply button, so reply. Okay, so even if you do mistake, no problem. So there is no point, okay, that you will be losing in order, so if you attend in this discussion. But I think if you do mistake, then by reading other people's discussion, you will learn something. As a human being, we always do mistake, right? Nobody is perfect. We learn from our mistakes. So that should be our goal, so that we learn from our mistakes. Yeah, so I like everybody to participate even in this question, and if I see that you are joining in this discussion activity collaboratively and interestingly, then I will post more questions. So then if I put more and more questions, then you will see that you will get some questions common or similar in your test, both in your upcoming test and in your final. Okay, but if I do not see, if I see that you are not participating actively, then I will not post. Then I think that, okay, you are not getting interest, so why I should do that? But if you like, then I can put the answer. If you like, then I can submit the answer as well, but I don't like to do that. I like you to figure out, to discuss yourself and figure out the question. And then in the discussion items, mainly one top thing I want to do intentionally. You will see that sometime I will do some mistakes or typo intentionally, so that I really want to see really you are giving focus. For instance, if I do this way, okay, if I do this way, then definitely your answer will be something different, that you would answer blindly. Okay, do not answer blindly. Okay, try to answer. So, and do not criticize me, because I'm telling that I will give some typo intentionally, so that I can see that really you are giving focus or not. Okay, so are you able to, okay, to anybody please help me. So are you able to submit anything? Can you please do that? I want to check that you are able to submit. Okay, in a few minutes I will revisit this. So everybody agree to participate in this discussion activity? Since I'm thinking we have some time, we are ahead almost, we are in the last quarter of this course. So how are you? Do you like? How are you? Okay, so let us see for the last few days. If you participate, if I see that more people are participating, then I will post more questions. But if I see that you are not participating, then I will not post. So let me see how do you feel it. Okay, that's good. So this is the discussion topic. So everybody is able to see the discussion topic, right? Okay, that's good. I see one. No, no, please submit your answer. For instance, answer A. What will be their answer for A, for B, C, like this, okay? I believe while analyzing these questions, you will be helpful and someone will learn from you, right? Someone will be helpful. Okay. Let's go to our last topic of this quarter. This is the stack and QE. So we were discussing stack, right? We discussed stack last week. Okay, there are three operations. Only there are three operations for stack: push, pop, and pick. Pick. Push operation is used to put a node into the stack, and pop operation is used to remove the node from the stack, and pick operation is used to just only to pick. It does not. It is the pick operation is different than the natural pickup. We pick up some fruits, right, from a garden. If we pick up some fruits, then we take away the fruits. But this pick is different. Is the spelling is different, right? Spelling also different, right? Okay. And then in our last class, I discussed stack. This is your section, right? I discussed stack implementation. Stack implementation is very simple. Like we have a node, same node is similar, very similar, and got exactly with our single linked list node. And then we have our stack class. This class contains a node that holds the top. Okay, every node in a stack knows who is the top. Okay, so then this is stack constructor. Although it is optional, even if you do not put top equal to null initially, it will by default put top equal to null. But it is better to put this constructor. And we have isEmpty method, and we have pick method. Pick method will work if the stack is not empty. If the stack is empty, there is nothing to pick. Okay. Similarly, if the stack is empty, there is nothing to pop. So the pop and pick operation, for pop and pick operation, we need to check whether first the stack is empty. If it is empty, then we don't need to do anything. We just need to return. Okay, or you can just we are putting this, or even we could put return over here. Oh, sorry. It will take return. It will take return if I do not give this. So either give a if it is empty, either give a instead of putting return, I like to give a message so that we can see that it is empty. And push operation is very simple. As I discussed, there are 4 lines mainly. First of all, we need to check if the top is null. If the top is null, then whatever element we will put, that will be the node. And if there are some existing nodes in the stack, then we have to change here this line, node dot next node equal to top, and then top equal to node. And the pop operation, actually the pop operation is actually this one line. This is the line, most important line. But since if the stack is empty, then it may give you an error message, exception error. So this is why we need to do this checkup. Oh, this is why I did not take return. It did not take return here because I need to give okay. If I give a closing bracket here, then it will take this return. So anybody has any question about stack? So these are the three operations, push, pop, and pick. You will get question in your upcoming test and in your final. Okay, for this. Okay, so now let us go to our QE implementation. I've already added a program in your section. Okay, there is a called QE implementation. This is QE implementation. Okay, a QE. Everybody here, you are very familiar with a QE operation. QE is a line of a ticket. So for every day you go to, for some time, you go to a train station or bus station in order to purchase ticket, right? So a QE, that you stand on a line, that is called a QE. QE is a FIFO type memory. FIFO means fast in, fast out. Okay, QE is a FIFO type, that means fast in, fast out. The person who will be coming in the line fast, right, he will be leaving fast. And the second person who will be coming next, and he will be leaving next. And this way, right? So everybody, every day we face and we do like QE operation. Okay, it's a line. Okay, so unlike a stack, what is the difference of a QE and a stack? Remember that a stack is one-sided. A stack was LIFO, last in, first out, right? Because a stack was like this. A stack was like this. For instance, the person who came here, and he would go all the way in, and the next one, and the next one, and this is the entry, and this is also exit. Only one exit. So a stack is different. A stack is different than a QE, because a QE you should remember it this way, that a QE is called a FIFO, fast in, fast out, FIFO type memory. Okay. Okay. There are only two operations. There are only two operations for a QE. One is in QE, that inserting a node into a QE, and DQE. DQE means deleting a node from a QE. Okay. Sometimes people misunderstand with this NQ and DQ method, that they think that NQ means deleting the QE, and they sometimes some people they think that DQE means deleting the QE. NQ means especially people misunderstand with DQE. Sometimes if we ask write a definition of DQ, they say deleting the QE. We are not deleting the QE. We will delete nodes, right? Entry or elements from a QE. That is called DQE. DQ operation, okay? And NQ is inserting. Okay. So, okay, this diagram it says some difference between stack and QE. Okay. So let us think about this. So from this picture, we know that a stack has only top, right? Okay, and a QE has a rear and a front. Okay, so if you think that this is, this is the flow. This arrow shows the flow. Then look at that. This is the front. That means the node was the person who entered into the QE at very first. Right? This is the front. And rear is the person or the node who entered or joined in the queue very last or very recent. So if we do a DQ operation, then who will be deleted? From the front. Because there is no way that it will be removed from this way. Okay, but if you add or insert a new element, where it will be added? In the rear. Right? So remember that if I want to delete all of the nodes from a QE, then what do I need to do? We need to delete the front node. When you delete the front node, the next node will be the front, right? Remember that the deleting operation. Let us go to the delete operation first. So if we delete the front node, so every time if we delete a node, that front will be changed, right? When you delete this node, then front will be that node. When you delete that node, the front will be that node. By this way, we will be deleting all of the node until we get front equal to rear. Right? When we see that front equal to rear, that means that is the so likely when we want to add or insert or NQ, do NQ operation, right? So then the rear will be changed, right? Now my rear is this one. When I insert another new node here, then the rear will be moved. And for the middle elements, you see that they are not tracked individually, right? They will be tracked. Okay, so if you want to delete, or if you want to display all nodes, right? If you want to display all nodes, in general we will start from the front. One by one we will display or delete. So deleting and inserting operation in a QE is very simple if you understand and remember the linked list operation, singly linked list, and stack operation. Then these are very simple. Okay, let us spend our next 10 minutes. Okay, please give attention, full attention for the next 10 minutes, and I believe everybody will understand. Okay, so please be focused for the next 10 minutes. So every queue, like a linked list or a stack, every queue has a node. Okay, a node contains some data and the node address of the next node. Okay. Some people may say that this is node, what this is the element, what this is tuple. Whatever you say, that is not an issue, right? That you see that this node class is very simple and very similar to our singly linked list node and our stack node, right? Nothing is different. You see that we have the same node. It's very simple. We have two data, ID and name, and we have our next node, and then we have node constructor, and we display node and toString. Let me return this toString with something different. Plus ID plus okay. So this node class is very simple. Everybody understand this, right? Okay. So then let us go to our queue class. So in the queue class, what we will do, we will put the methods in order to our mainly our okay. Why do we have peak operation? Okay, I can do peak operation actually. That's good. We have peak operation as well as. Mainly we will do NQ and PQ. Let me see if it runs. Long time. Okay. That is good. So let us see that the queue class is very simple, and then queue constructor. So a queue contains all queue. The queue class contains two things, two nodes, one for top and one for tail, right? In the okay, so in the figure it says rear. Okay, my program it has tail. Okay, it's identical, right? Synonymal, right? Understandable, right? Okay. And the top that means front. Okay, either this is front is my top, and tail is my. Okay, I can rename this. How do I rename it? You see that we can refactor, right button, and then rename, and then make it front, front. Okay, one click. Okay, and the tail will be rear. REAR. Okay, so by quickly I did Shift, Walter, and R. I press Shift, Walter, and R, then it will come quickly. Okay. Instead of top, I put front. Okay. Front and front, and maybe I maybe put front, and instead of there was tail, right? Tail will be rear. Instead of tail, it will be rear. Okay. Now it is very similar with the slide. Okay. Okay. Here you can see that is empty method is their front equal to null or tail equal to null. You can say both. Either you can say. Okay. Or maybe there is a way if front equal to tail rear. Then it is also no. If it is front equal to rear, then there will be one node. Okay, either front equal to null or rear equal to null. This will be our empty check. Okay, and then pick method is very simple. It will tell the front ID. Okay, so mainly we need to understand these two methods, NQ and DQ methods. Okay, let us spend for the next 10 minutes. Okay, the NQ is very simple. I'm enqueuing like I'm giving when I'm putting in data, then when I'm doing NQ operation, I am also giving ID and name. Okay, and then whatever ID and name I'm putting, those ID and name will be going to my node, will be going to my constructor. Okay, this line. And here, if rear equal to null, what do you understand from this line? If rear equal to null, yes. If rear equal to null, that is empty, right? My queue is empty. So if queue is empty, then let us do. Okay, is empty queue? Is empty. Okay, empty queue. Okay, so then whatever I put, the node I put, yeah, that will be my front and rear, right? When there will be only one node. So this node will be my front, this node will be my front, as well as it will be my rear. Everybody understand this? Because when I did not have any element in my queue was empty. So at that point, when I put a node, that will be my first node. Okay, at this point, my front and rear will be initialized by the node, whatever I will be inserting by this node. Okay, everybody understand this? Okay, now let us go to this else condition. Else condition means what? Else condition means my queue is not empty. It has at least one node, right? So if it has at least one node, so then for instance this is my node I already have. If I want to insert another node, then where that node will be going? Let us give my flow like this way. This is my flow. It will going here, right? No, sorry. Front, sorry. This will be actually I wrote my front over here, so it will be like this way. I did a mistake. Thank you. It is not giving me. So when I put one node, this node is a front and rear, right? If it is front, it is also front and it is also rear. Okay. So if my flow is this way, so then in the QE, okay, the element first come first serve, FIFO, right? So then the next element will come here. This element will be added as a rear, in the rear position here. Okay. So then my rear will be changed. This line, you see that? Rear dot next equal to rear. So this previously this was my rear, right? Initially it was my rear, right? Before this operation. So rear dot next equal to, that means it will go in an empty place. This place we do not see yet until we put this node. You have to imagine that. When you say rear dot next, that means there will be an empty place created, and on that empty place this node will be placed. So that means my rear will be this one instead of that one, previous one. And my front will be unchanged, right? In that case, my front will be unchanged for NQ operation. You understand? So the DQ operation is reverse order. Think about the DQ. So if you want to do DQ, then which one will be changed? My front. We are deleting from the front, right? So for the DQ operation, this front will be changed, and for NQ operation, the rear will be changed, since we are adding in the rear. So now look at this. If you remember this, you see that now let us compare the NQ and DQ operations side by side. So here all codes are here almost. If you look at this code, you will see that in the DQ operation only, actually this is my vital line. Other thing is blah 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 blah. Okay, that this line is just checking, right? If my front equal to null, that means we are making, is this required or not? I don't know. Maybe this is not, or this is optional, or we can check that. This is the thing that we are checking if the DQ is null. Yeah. And this is the stuff. Otherwise, this is the condition. These three lines I just wrote in order to show the message that is deleted. Okay, but this line is if you are asked to write a program, okay, this line is optional. These three lines, and this is the most and only one important line of code. Try to understand that, whether you understand this line. And this line and line number 53, okay, line number 53, 54 for NQ, and this one is the DQ. So the codes are in the GitHub repository. Okay, please get the code and run this program and try to understand the effect. Okay, so I have some output. Let me Let me make it simple. 1A, 2B, 3C, 4D, 5E. Okay, we have too many in QDQ operations. Okay. Let us try to understand one by one. Okay, we will finish our class in 10 minutes. Until you have not any question. Okay, I want to run until I want to see output until this. Okay, until this point. Let us try to understand. So until this, I want to see output up to this. Okay, so this line is Q implementation explained. This is this line number 2092. Okay, and then we just created a QE. My QE equal to new QE, and here we entered an element, a node into my queue with the in-queue operation, right? The node ID is 1 and the name is A. Okay, so these values are coming from where? Anybody can guess? From which method this value is coming from? TrueString method. It is coming from the TrueString method. You see that my TrueString method where? You see this one? If I say my TrueString is like this, if I say my TrueString is like this, you see that only my, you see, is only coming A, right? And if I say node plus name plus something plus ID, okay, then it will come name and ID. You see then name and one. So this is coming from TrueString method, but we do not name. We never call TrueString method explicitly. TrueString method is called explicitly. We do not call TrueString method implicitly. Okay. So we are seeing output from here. So here my front equal to A, right? Okay. So here at this point. Okay, here. So when I have only one node A, so who will be front? This A node is front and A, rear, right? Both, right? So this is why it is showing me front equal to A and rear equal to A. Okay, but okay, so then when I have only front one, then front dot next equal to null. You see that front dot next equal to null. So this is why it is showing front dot next equal to null. Just checking, maybe I added few lines to check front dot next equal to null, rear dot next equal to null. And here, if I go to this statement right now, if I add one more element, one more node, then who will be my front? My front will be A and my rear will be B. Let us see if you understand this. Okay, if I add one more element, then my front will be A and the new element will be added in the rear, right? The back. So the rear will be B, and then front dot next will be B and rear dot next will be null. Like this way. For instance, this is my QE and this is front, that means, and this way it is coming, this is rear. So if I add one element A with 1 with A, ID 1, so when I have only one element, then it is itself front and itself rear. Okay, then this front dot next will be null and rear dot next will be null. That means that this way null. Okay, and when we add another element here 2 with B, then who is my front? My front will be unchanged, right? My rear will be changed. Previously my rear was 1, that this time rear was not 2. Okay, then if I say my front dot next, then it will be B, right? Front dot next will be this one. And if I say this rear, and this rear dot next will be empty, null, nothing. Okay, so this way we can trace the nodes of a QE one by one. Okay, so everybody understand at this point? Q operation is very simple. It's not okay. So sometimes if I do pick operation and then let me understand our ability. If I say some DQ operation, okay, 2, okay, 2 like this way. Okay, at this point, let me run this program at this point. Okay, can anyone please help me to tell me the sequence or current state of this stack? So let us do. I have my this NQ and D. Look at the statement with NQ and DQ operation. So I say NQ operation in A, right? 1. So then node 1 will be added, right? If I say NQ, then node B will be added, right? So then if I say DQ twice, then what will happen? Yes, this should be empty. Let us check whether it should or not. It must be empty. Okay, let us give this to okay. So after, remember this, after this we will check before this. Yeah, actually deleted. Actually the node with, here you see that the node with ID 1 is deleted and the node ID 2 is deleted, right? So even if I, after this, if I do a pick operation, over here, there is nothing to pick, right? This is empty, right? Okay, and then after if we do this NQ, then what will be added? C, right? And then after that D will be added, and then if we do DQ, which one will be deleted? Huh? You said D? Why? That was very fast. So at this point our Q is empty. Then we added a new item, C. That will be the only one, right, at this point? Okay, and then D will come next to C, right? Then if we delete, if we do DQ, then which one will be deleted? First come first serve. C came first, right? C will be deleted, right? So let us do a, okay, I think that my delete operation, it has a message. Who is deleting? Okay, the delete operation has a message. Who what is deleted? I'm sorry. And then after that, if I do another NQ operation, then this E will be added, right? So then my last status of my Q will be with D and E, right? Let us check. Everybody understand this? What is my mistake? There is no node to delete. And then ID equal to 5 and E. Only it is showing only one node. Why? Let me do a peak version. Okay, after this. There is nothing to pick. DQ, but here I have only one. Thank you. Let me run this again. Why am I getting this? Doing any mistake? 20 crores. Give some stars. And then NQ and NQC and D after star. There is nothing to delete. Why my NQ is not working? I don't know. I will check it and let us check everybody. So what is my mistake? There is something, maybe something that is a DQ. How many DQs I do have? B, C, and D. Between these two, node 2, only 2 nodes, right? So that means 2 and DQ 2. Let us rethink. My code is there. Can anybody please check? And then if there is any mistake in my code, and then we will go to next week. Okay, anybody have any issue? Let us check this code, okay? If there is any mistake on run, if my brain is not working. Okay, so again, some people came late, so we discussed in the beginning of this class that I am adding some discussion topic. Okay, so I like everybody to join in this discussion topic, and if I see that you are joining actively, then I will post more similar discussion topic or question. Then probably you will get some questions, similar question in your test. And by this time, while you will participate in this discussion board, you will be prepared for your upcoming test and for your final. I like to see everybody will get at least B in this course. Okay, you are spending your time, you are spending your money at this night time, you are coming here. Okay, so why should not you do well in this course? Okay, and then, as I mentioned that I will put in some intentional mistake. Even if I go put some mistake in this code, some course, okay, try to figure out what are the mistakes and how to fix it. That's good. I like this kind of active collaboration. Okay, and when someone posts this and other people please verify whether this is this correct or not. You see that maybe I gave orientation. Okay, I will give some maybe some. Okay, there is no R. Okay, anybody has any question so far? Sir, we have covered last minute. We have covered at least 70% of this course, and you know that your next test will be test 3 on 19. Okay, we will cover from week 6 to week 9 until today's class. Okay, reference parameter, recursion, linked list, okay, and stack and queue. Although recursion parameter is only for mainly for C#, Java does not allow call by reference, right? But people who are taking even Java, in your test, if you are given this kind of question, you cannot say that, oh, I did not check C#, so that reference or out keyword is not in Java, so I'm keeping it empty. That will not be an excuse. You have to learn it, okay? This is the foundation. And in our next class, we will learn an interesting thing about exception handling, okay? And then we have how many topics here? Exception handling, file and IO operation, thread and parallel processing, and BST. Okay, 4 topics, 4 weeks. I think 1, 2, 3, 4. Yeah, 4 weeks should be fine. When is our spring break? Early February, right? Early April. Anyone has any question?